Hello kids! In this video we're going to talk about what the prime factors are and also the prime factorization, which are two really similar and related concepts, but they have their differences. So in the previous video we learned how to find the factors of any natural number with a really simple and straightforward process. And we did it with the number 16 and with the number 20. So for this occasion we are going to use the same examples. So remember, the list of the factors of 16 is 1, 16, 2, 8, and 4. Now, not all of those numbers are prime. Remember, here are the list of the first prime numbers. They are infinite, but we will probably not need more than this. So let's try to find what of the factors of 16 are prime. And here we can see that the 1 is not prime, 16 is not prime, the 2 is prime, the 8 is not prime, and the 4 is not prime also. So we can say that the factors that are prime of 16 are only the 2, is only the 2. Only the 2. Okay, now let's do it with the 20. Let's do it. I am going to do it a little bit here. 20. Okay, so 1 is not prime, 20 is not prime, 2 is prime, 10 not, 4 not, and 5 is prime. So we can say that the prime factors of 20 are 2 and 5. Okay, this is really easy. But now we are going to talk about the prime factorization, because every natural number can be expressed or represented as a unique multiplication of only prime numbers. So we can say that the number 16 can be written as a multiplication of only prime numbers, but we cannot say that 16 is 2. No, we should say that 16 is 2 times 2 times 2 times 2. That is 16, and this is a unique multiplication of prime numbers that results in the number 16. Okay, we can also do it with the 20, but we cannot say that the number 20 is 2 times 5. No, the number 20 is instead 2 times 2 times 5. This is a unique combination of prime numbers that if you multiply, you get the number 20. Okay, this is the prime factorization of 16, and this is the prime factorization of 20. But if you do it with bigger numbers, it is going to be difficult, because you need first to find all of the factors, then check if the factors what factors of them are prime, and then try and make mistakes of finding what is the unique combination that of those prime numbers that you can use. But there is a process that you can use instead. So let's do it with the number, I don't know, let's say, actually, let's do it with the same numbers. Let's do it with the number 16 first. So if you do it with 16, you're going to find that first you need to divide the number 16 by a prime number. So let's try with the prime numbers in order. Can you do it with the 2? Can you divide the 16 by the number 2? The answer is yes. So you put the result here, and the result of 16 divided by 2 is 8. Now the question is, can you continue with the 2? So can you divide the 8 by the 2? The answer is yes. The result is 4. Can you continue with the 2? Yes. The result is 2. Can you continue? Yes. And the result is 1. Once we get to the number 1 here, it means that we finished, and that these numbers, if you multiply them, 2 times 2 times 2 times 2, you are going to get 16. You are going to get this number. Now let's do it with the number 20. Because look, the result that we got here is the same that we got here. Now let's do it with the number 20. 20. Can you start with the first prime number, the number 2? And the answer is yes. If you divide 20 by 2, you get 10. Can you continue with the 2? The answer is yes. And the result is 5. Can you continue with the 2? In this case, no, because you cannot divide the 5 by 2. So we have to forget about the number 2 and move to the next prime number. Can you do it with the 3? Can you divide 5 by 3? The answer is no. So let's do it with the next number. Can you divide it with the 5? And the answer is yes. And 5 divided by 5 is 1. So once again, we finished because we got 1 here. So it means that 2 times 2 times 5 is 20. The same number that we had originally. And look, it's the same that we got here. So that is how you make prime factorizations.